Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is middle of linked list. So the problem statement goes like this: given the head of a singly linked list, you have to return the middle of the linked list. Okay, so if there are two nodes in the middle, you have to return the second middle node. Okay, so for example, it was a even length linked list here. Let me take it to the board. This particular list is a even length, so you have to return, and there are two nodes in the middle, these two, so you have to return the second middle node. Okay, and if let's say the list that is given to you is a odd length list, then it's okay. Here I beg my pardon, it was a odd length list, so we will be directly returning the middle node. Okay, and in the another example that is there, then this one is a even length list. Okay, so there are even number of nodes in the list that I will be just pasting here. Okay, this one is even. So there were two nodes in the middle, these two. Okay, and it was a even length list, so we will be returning the second middle. So this is what problem statement mean by this is second middle node if there are two middle nodes. And let's have a look at the constraints also. So the number of nodes in the list will be ranging from 1 to 100, and nodes value are from 1 to 100. Okay, so let's see how we can solve this. What we can do is we will try to solve it in the most optimal way possible. So we will be having two pointers here. One will be your pointer, which will be moving at a speed twice than the other, so you can call this fast moving pointer. Or for the sake of simplicity, let's just call it fast pointer. Okay, fast only. Okay, so this will be moving at twice the speed of slow. Another pointer will be slow, so the speed relations will be speed of fast is equal to twice of speed of slow. So the distances covered by them will also be similar. So number of nodes covered by fast is equal to twice the number of nodes covered by slow. Okay, so initially both of the pointers will be positioned at the head of the linked list, so this is the head. Okay, then your fast pointer will be jumping two nodes in one go. Okay, like this, it will be ending up in 3, and slow will only jump one node in one go. Okay, so slow will be here, and then fast will again be jumping two nodes. It will be here, and slow will be here. Now when it happens, when fast will be either at the null node. Null means that we are at the end of the list. it means that this particular last node is having no other node next to it. Okay, so either your fast will be a null node or fast next would be a null node. Okay, it means that we are at the end of the list. So when fast will be at this position, where would your slow be? Slow will be at a position which is just required for us to return. Okay, so if fast have traveled, you know how many number of nodes fast have covered? 4 nodes. So how many nodes would slow cover here? 4 divided by 2, since they were moving, this relation will hold true for the number of nodes covered. Okay, because of the speed that they were having relative to each other. Okay, so number of nodes covered by this is fast, and number of nodes covered by slow will be 2 nodes. So your slow will eventually end up in the middle of the linked list. Let's try for even length example. Okay, so initially fast and slow will be both here. This is your fast and this is your slow. Okay, now fast will be jumping 2 places, eventually ending up on 3. Slow will be jumping only 1 place, eventually ending up on 2. Then from 3 fast will go to 5, and from 2 slow will only go to 3. Now after 6 there is no other next node, so we will be just pointing to the null. Okay, and after 5, where will this fast end? Fast will be ending at null. So here is the thing that here is the point or the instance when we will be terminating. Okay, and before terminating we will be moving slow 1 position at a time, so it will be at 4 when the whole thing will terminate. So we will indeed be having the second middle node in case of even length. So that is what we were requiring to return at the first place. So this is how this algorithm will work out. Okay, moving a pointer twice the speed of the other pointer will result in it covering twice the distance than the other pointer, and when this fast moving pointer will be at the very end of the linked list, the slow moving pointer will be just at the right position that we have to return. Okay, so this is the whole logic. Let's try to implement it. Okay, so we'll be implementing it quickly. So the code will be available in both of the languages, C++ and Java. So right now I am implementing in C++. So I am declaring 2 pointers, both of them being pointed to the head of the linked list currently. Okay, so fast and slow. And then what I am doing is we will continue this whole process till the fast is at the very end of the linked list. Okay, and this will continue till fast is not at the end of the linked list. So fast should not be null, and this should also not hold true, that fast dot next should not be null. Why these 2 cases? Why not only single one? Because here you will see that fast dot next is null here. Okay, and here fast will eventually be null only. Okay, so that's why these 2. Fast should not be equal to null, and fast next should also not be equal to null. Only then you will be able to make a jump of 2 nodes with fast. Okay, so fast will be jumping 2 places in one go, or 2 nodes you can say, and our slow pointer will be just jumping 1 place in one go, or 1 node. And then when this whole thing will terminate, your fast will be either at the null node or the very last node. Okay, and now what you will do, you will just return the slow pointer that is there. Okay, hopefully it will get accepted in the very first go. Okay, we have done a syntactual mistake here. Instead of dot, it should be this. I don't know what we call this symbol, but this is what it is in C++. Okay, so I think it should work just fine now. Let's see. Okay, it's taking a little time. I don't know, maybe. Okay, it's getting accepted for in sample test cases that were there. Let's submit for the final evaluation. Okay, it's getting accepted for the all of the test cases that were there. So this is how we will be solving this particular problem. And you ask about time and space complexities. Let me take a new slide. So time complexity wise, it will be order of n only, where n is the number of the nodes. Okay, and since we are just doing a linear traversal here, and space complexity wise, since we are not using anything other than just we are playing with pointers here, so it's a constant space complexity solution that we have just implemented. Okay, so if you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.